Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's Algebra 2 class. Today we're going to continue our discussion on systems of linear equations. Last class we learned how to solve systems by graphing. And what we do in those situations when they say to solve by graphing, you're going to go ahead and solve each given equation for y. You're going to put it into y equals mx plus b form. Then you're going to go ahead and graph both of those equations, and you're going to find the point of intersection where both points intersect. No sarcasm, that's what we're looking for. Sometimes, though, we're given word problems or equations in the system that are not so easy to graph, or the numbers are very difficult, or there's fractions or decimals, and it's very difficult to graph those. So that's why the graphing method is the least efficient of all three. So when we have situations where we have word problems or numbers that are, or equations rather, that are not easy to graph, we're going to use what's called substitution, okay? We still have substitution and elimination to learn. Today we're going to learn substitution. And the substitution method, okay? Before I even start teaching these steps, think about what substitute means, okay? What does it mean when you have a substitute teacher? Sir? I love the wording of that. It replaces your real teacher. Very good. It doesn't mean that it's the same person. It means it's a replacement. There is a teacher that day, and instead of having me as that teacher, you're having a different human being in my teacher role. That's what a sub means when you substitute. Or in football, you know, you get your starting wide receiver that gets injured, so you have to substitute them in with your next wide receiver, correct? You're replacing one. I love the way you said that. You're replacing. Very good, very good. That's what's happening here for substitution method of solving systems of linear equations. What you have to do in this particular case, guys, when you're giving a system, number one, is choose an equation and solve the variable of your choice. Try to choose the easiest one to solve for. So you're given two equations here. You're given this green guy and you're given this blue guy. I want to choose from one of these equations the easiest variable possible to solve for. So when you look at these, which is the easiest variable to solve for here in your opinion? Yes, sir. Okay, what variable from the blue did you want to solve for? Y would be the easiest one to solve for. And how do I solve that? I subtract 2x to both sides. So now I know that y equals negative 2x plus 10. That is your goal. You don't have to solve for y per se. You don't have to solve for x per se. But you do have to solve for one variable. Solve for the variable that you find easiest to solve for. You're going to have a lot of choices here, okay? You could have solved for any x and any y. But me, I strongly suggest solve for the easiest variable possible. Now you know that y equals negative 2x plus 10. Now that you know what one of the variables equals, we're going to go to step 2. Substitute the expression for the variable you just solved for in the other equation. Then solve for the other variable. So we use this blue equation to find what y equals. Everyone's with me there, my brothers? So now I'm going to take this value of y, which is negative 2x plus 10, and I'm going to literally substitute it for the y in this first equation. Do you see what I'm doing here, guys, before I actually do it? Okay, I'm going to take that as a yes. So I've got 3x plus 4y. But we already know that y equals negative 2x plus 10. So I substituted that value for y equals 12. And now let's solve for x. So I've got 3x minus 8x plus 40 equals 12. 3x minus 8x is negative 5x. plus 40 equals 12. Go ahead and subtract 40 to both sides. And you're going to get negative 5x equals, what is that, negative 28. And then divide by negative 5. And x is going to equal 28 fifths. I put a very ugly one to begin with, guys, because life is not always pretty. I want to show you from the beginning. You can get ugly numbers with this, and that's fine. In fact, that's why we don't graph for the most part when we're solving systems, because a lot of times you're going to get ugly numbers. So does everyone understand and see what I just did? I found what y was. I substituted y into this second equation up here, and I solved for x. Does that make sense to everybody? Everyone sees the math, what I did, how I did it? Promise? Okie dokie, Smokey. All right, so now that I have x is 28 fifths. Now step 3, substitute the expression for the variable you just solved for in the other equation, solve for the other variable. So now that I know what x is, guys, let's go back to this equation here that told you what y was. Y equals negative 2 times x, which now is 28 fifths, plus 10. So I have y equals negative 56 fifths plus 10. Remember that 10 has a denominator of 1. So that goes to 5, that goes to 50. So y equals negative 6 fifths. So what is my solution? My solution is 28 fifths, comma, negative 6 fifths. If you plug these two values into the original equation, both equations will be true. And that is how you solve using substitution. It's not going to get any uglier than this, guys. I started out with an ugly one on purpose. I want you to see that fractions will be a reality. We've got to know them. Okay? Questions before we continue, my brothers? Yes, sir. Thank you so much.
So for that last y value, you can plug into both systems or just
you can plug this y value back into here or here, but I wouldn't do that. Didn't we already solve for y right here? So once I have x, wouldn't it be easier to plug the x into this y equals equation already? Does that make sense, son? To answer your question, though, yes. You could have plugged it in here, you could have plugged it in here, but that's going to be more work for you. So if you already know what one of the variables equals, once you find the other variable, just plug it in to solve a little bit easier. My suggestion, though. Does that make sense, though, to you? Okay. Thank you, my brother. Questions, my brothers? This is the time to ask, please. Yes, sir, my brother. Yes, sir. Of course I can move the screen down. What's up? You have a question on that? Okay. All right, guys. All right, we are going to move on because there is a video for this, guys. So move it on unless you have any questions. Now would be the time. Sir. Okay, thank you, my brother. Okay, so let's solve each system here. Let's do it. Well, for one variable, yes. We already know that y equals negative 2x plus 10. So I am literally going to take that y value and plug it into the y. So I have 3x plus 5 times y, which is negative 2x plus 10, equals 8. All I did was I substituted the y into the second equation. Does everyone see that clearly before I move on? Please be honest, guys. Okay, so I've got 3x minus 10x plus 50 equals 8. 3x minus 10x is negative 7x plus 50 equals 8. Subtract the 50 to both sides. Negative 7x equals negative 42. Divide by negative 7. X equals 6. Now that x equals 6, I can plug that 6 into any equation I want. I could plug it in here or in here. But which do you think would be the wisest to plug it into? The top one. Why? To make your life easier, my brothers. You know that x equals 6 already, so y equals negative 2 times 6 plus 10. Negative 2 times 6 is negative 12, plus 10 is negative 2. So you know that y equals negative 2. And my solution is 6 comma negative 2. And you can plug these in to test it. Y equals negative 2. Well, negative 2 times x, which is 6, is negative 12. Negative 12 plus 10 is negative 2, so it works. 3 times 6 is 18. 5 times negative 2 is negative 10. 18 minus 10 is 8, so they both work. If they do not work in one of them, then it is not a solution. Exactly like graphing. Okay, how about B? Who do you guys want to solve for first? Which would be the easiest variable to solve for? Okay, in the first equation, which variable? The y. Very good. So me personally, I'm going to take this over here. I'm going to subtract 2x to both sides. And I've got negative y equals negative 2x minus 15. Divide by a negative 1. So y equals 2x plus 15. All right. That value I'm going to plug into this y. Does that make sense, gentlemen? Talk to me, boys. Okay. I'll take that as a yes. So now I've got 4x plus 3 times y, which is 2x plus 15, equals 5. So I've got 4x plus 6x plus 45 equals 5. 4x plus 6x is 10x plus 45 equals 5. Subtract 45 to both sides. 10x equals negative 40. Divide by 10 to both sides. X equals negative 4. Once I have x is equal to negative 4, I could plug that x into either one, but exactly like you said, my man, I would plug that x into this equation because I'm looking for y. So y equals 2 times x, which is negative 4, plus 15. Y equals negative 8 plus 15. Y equals 7. My solution is negative 4, comma 7. I can plug it in to see if it works. Negative 8 minus 7 is negative 15. It works. Negative 16 plus 21 is 5, so it works. Questions, comments, concerns, pitfalls, problems, anything at all, brothers, before we continue? Okay. Thank you very much, gentlemen. Okay, how about here? Let's switch it up. What would be the easiest thing to solve for here in your opinion? Yes, sir. The first one, you want to solve for the first one? I would think solving for this x would be easier, right? Because all I'd have to do here, gentlemen, is subtract 2y to both sides. So I would know then that x equals negative 2y plus 13 over 2. Now, is that pretty? No, it's not. But do I care? No. Very good. And I'm not being sarcastic, but the reason why I don't care is because in the SAT, they're not going to be pretty either. You guys can handle this, and I know you can. So, I'm going to take the value of this x, and I'm going to literally substitute it in here. So I've got 2 times x, which is negative 2y, plus 13 halves, plus 3y equals 9. When I distribute, I get negative 4y plus 13. See, the fraction went away anyways. Plus 3y equals 9. Negative 4y plus 3y is negative y. I subtract 13 to both sides. So negative y equals negative 4. Divide by negative 1. Y equals 4. And if y equals 4, now I plug it into here. So I've got x equals negative 2 times y, which is 4, plus 13 halves. So x equals negative 8 plus 13 halves. But I got to find a common denominator. The denominator of negative 1 is a 1. The common denominator is 2. Good job. So that goes to 2. That goes to negative 16. So x equals negative 3 halves. So what is my solution? My solution for this guy would be negative 3 halves, comma, 4. Does that make sense, guys? Yes, sir. It does not matter if you solve for x first or y first. What does matter is solve for the easiest variable to solve for. Letter D. What do we got here, guys? I would solve for this x up here, absolutely. So I'd add 3y to both sides. So x equals 3y plus 5. So let's go ahead and substitute that x value into this x of the second equation. So I've got negative 2 times x, which is 3y, plus 5, plus 6y equals 3. Negative 6y minus 10 plus 6y equals 3. Wait a second. Negative 6y and 6y cancels. So I've got negative 10 equals 3. My brothers, is that a true or a false statement? So if it's a false statement, it would be no solution. You can stop. You don't have to do anything else. If you get a false statement, that means there is no solution. So if there is no solution, what does that tell you about the slopes? If there's no solution, what does that tell you about the slopes? Okay, that the slopes are the same. Okay, the slopes are the same. When the slopes are the same, they're parallel, there's no solution. Give me 1 second, please. Let me just check. Okie dokie. So yeah, again, guys, if you have a false statement, there's no solution. And it's no solution, then that means that the slopes are equal. Very good. Okay, how about this bad boy? Who do you think we should solve for first? Yes, sir. Yeah, I would solve for that guy. So I'd add 3x to both sides. So y equals 3x plus 2. I'm going to take that y value and literally plug it in to that y. So I have 6x minus 2 times y, which is 3x plus 2, equals negative 4. Anyways, so 6x minus 6x minus 4 equals negative 4. Those cancel. Hey, wait a second. Negative 4 equals negative 4. Is that a true or a false statement? Yeah, negative 4 equals negative 4. That's a true statement. So if you have a true statement, this would be all real numbers, or you could say all real solutions. Or you can use the symbol for all real numbers, which is basically an R but with a second backing to it. That symbol there means all real numbers. So when you're doing these by substitution or elimination, you'll see it's the same thing. If you have a true statement, it's all real numbers. Any x and y will work. If you get a false statement, that means that no x or y will work. That's a no solution. Does that make sense, gentlemen? Okay, you promise? Okay, now let's talk about how this works with word problems. This is what you're going to see in the SAT. This is what the real use of systems are. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music, books, CDs, software, etc., are shown in the advertisement. What is the cost of each lesson and the one-time fee for materials? So far, whenever we've talked about word problems, what do I like to do first? Starts with an L. Label, label, label. Thank you, my brothers. So me personally, I'm going to say that X equals the number of lessons. And I'm going to say that Y is the one-time fee. Because there are two different things that we're talking about, right? We want to get the cost of the lesson, and we got to get the one-time fee, right? Okay, you with me here? Okay. So in this particular case, I was given two different sets of possibilities. I have 6 lessons for 300, and I'm sorry, it's not the number of lessons, because they tell you the number of lessons. It's the cost of lessons. I should learn how to pay attention. What is the cost of each lesson and the one-time fee? So we're looking for the cost of each lesson and the how much the one-time fee is. So I've got 6 lessons times X, which is the cost per each lesson, plus the one-time fee Y, that equals $300. Another option that I have is 12 lessons, 12 times the cost of each lesson, plus still the one-time fee to give me $480. If you had written that down, and I expect you to graph it, there'd be very, very inaccurate answers there. That's why we learn substitution elimination. Now I know, but let me ask you, which one do you want to solve for here, guys? The top Y. Okay, so I'm going to subtract 6x to both sides. So Y equals negative 6x plus 300. I'm going to literally take that value and plug it into this Y, giving me now 12x plus Y, which is negative 6x plus 300 equals 480. Do you see what I did there, guys? So 12x minus 6x is 6x. I'm going to subtract 300 to both sides. That equals 180. So x equals $30. Okay. So if I know what x is, then what would y be? Y equals negative 6 times 30 plus 300. So y equals negative 180 plus 300. So y equals 120. So what is my solution? $30 per lesson and 120 for the one-time fee, or in an ordered pair, 30, 120. That's how you solve using substitution. Label, guys. If you label, life is a lot easier. I promise you. Any questions on the setup, on what I did? Yeah, anything you need. That's why I'm here. You can use elimination. and when we get to elimination, you'll have all skills, then yes, you would be able to solve it any way you wanted. Good question, son. Thank you. So the real important part here is, besides solving, of course, label. If you label, you're going to get some points for that at least. Set up your equation, your system. You set that up, you're going to get some points at least. And then, of course, you got to solve it. That is the whole point. But sometimes you label correctly, you set up the equations correctly, and you're a human being, you mess up one negative. I'm going to give you partial for that. Because that tells me that you know what you're doing. You're just a human being and you messed up with a negative. But as long as you got your equation right and you labeled correctly, you should be golden. But if you go ahead and just give me answers, guys, I cannot help you. I cannot give you any credit at all if you just give me answers. Does that make sense? Is that fair? Can you understand why I would do that? Okay. Any questions before we move on to our last example, my brothers? Okay, thank you very much. Let's knock it out. Okay, here's a good one. The participation rate in the workforce is defined by economists to be the number of individuals employed divided by the number of individuals 16 years of age or older. The participation rate for men is P equals negative 0.08T plus 243.96, where T is the year. The participation rate P for women is given by P is equal to 0.24T minus 415.10, where T is the year. Based on these models, when, if ever, can we expect the participation rate of women in the workforce to equal the participation rate of men? Luckily, they gave you the equations already. Didn't they tell you what the participation rate P was for men and the participation rate P was for women? Doesn't P equal P? Aren't they the same letter? So when will the participation rate of men, 0.08T plus 243.96, equal the participation rate of women, 0.24T minus 415.10? You literally set P equal to P. You set them equal to each other because they were the same variable. Now it's just a matter of subtracting and adding and solving. So I'm going to add 0.08T to both sides, gentlemen. And at the same time, I'm going to add 415.10 to both sides, gentlemen. So what that gives me is, okay, I got a 6, 0, 1, that's 9, 5, okay, 659.06 equals 0.24 plus 0.08 is 0.32T. In a situation like this, I would allow you to use a calculator. I would. So 659.06 divided by 0.32. T equals 2059.5. So roughly in the year 2060, there will be the same participation rate in the workforce of women as of men. Does that make sense? Now, please understand, this isn't because men are better, guys. I want you to understand this clearly. Remember that women have to give birth. So a lot of times, women are not in the workforce for the beginning parts of their child. So please don't leave going, yeah, men rule. No, men don't give birth. Remember that. And also, women live longer than men. So what happens is eventually the population will start becoming more topside on the women's side than on men. And then there will be just as many women in the workforce as men. Guys, I hope this made sense. Hope you learned a lot. Have a wonderful day, and thank you. Take care of yourselves. Be good.